today, this is going to be on the even page. We're going to write down our notes. You don't need to write those words, just to remind you what page of the 2 pages you're going to be working on. So the title for our notes is Estimating Irrational Numbers. Now, in the video that you guys were asked to watch last night, he estimated his numbers to the nearest tenth. I'm going to ask you to, we're going to do it 2 ways. We're going to round it to the nearest integer and also use his method to get it to the nearest tenth. All right, so first off, let's talk about the definition of what is an irrational number. And basically, the definition we're going to use is going to sound a lot like another definition we have. So an irrational number is a number that, and I'm going to change to color and capitals, so I'm kind of yelling at you, cannot be written as the ratio of 2 integers. So when we did that worksheet Monday night, anything that didn't fall under rational, integer, whole number, and natural number, we just kicked over to that other column to the right, which was the irrational column. So let's put a couple things what's in there. There are decimals that are allowed to be irrational, but they're very specific kinds. They are non-repeating, non-terminating decimals. So here's an example of one. 1, 2, 4, 6, 8, 2, 3, 7, dot, 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 dot. In other words, nothing is repeating. There's no pattern to follow. It doesn't make any sense. It's not the same things over and over. This pattern, however, is still considered irrational. Even though I could predict probably what would come next, because I do see a pattern, it's not repeating. Repeating means the same thing over and over and over again. In this case, the 1 shows up and then a 2, and then a 1 shows up and 2 2s, and a 1 shows up and 3 2s. So the 2s continually grow. That is considered irrational. Now, we have a symbol for the most common. When we say irrational, most people think of this symbol. What do we use in math that is irrational? Brittany? Pi. Okay, so pi is definitely what we call irrational. And then the one that is relevant to today's notes is square roots of non-perfect squares. So any number that's not a perfect square that comes under a radical sign, that's going to give you an irrational number. And the only way to get the answer is to estimate it, which we're going to have in our notes today, or to use a calculator. Okay? And again, the number you would get on the calculator would be non-repeating, non-terminating. All right? So at this point, we're going to kind of leave the even page, and now we're going to go to the odd page, and we're going to do an example. After that example, we're going to come back to the even page, and we're going to write in words, what did we do in the example, and then we'll try to get 2 more examples in. So everybody good for me to move? So now we're on the odd page, and the directions are going to say, estimate to the nearest integer and nearest tenth. And by the way, if you guys didn't think about it, I would recommend that you subscribe to that Fort Bend Tutoring channel on YouTube because they have a lot of really good videos on a lot of different topics we cover. So it's good to have that. Okay, so our first example is going to be the square root of 83. Now, in order to round to the nearest integer, it's like doing the groundwork that he did in the video. And then after we get that answer, then we're going to continue on in his process to get to the nearest tenth. So first thing we need to do is to figure out what two perfect squares does that radicand 83 fall between. So this is why it's so important for you to know your perfect squares. Come the quiz, which by the way will be next Wednesday, there will be no chart available to you. It has to come out of your brain. So spend some time this weekend making sure you memorize. All right, what are two perfect squares that 83 fall between? Aya. 81 and 100. But we're not interested in 81 and 100 because if you notice, my original problem has a radical around them. So we need to look at the radical, or the square root, of 81 and the square root of 100. Okay? And what is the square root of 81, everybody? 9. And the square root of 100? 10. So what this says is my answer rounded to the nearest integer is either going to be a 9 or it's going to be a 10. So our job now is to figure out which one. So next, we're going to do a little subtraction to see which of our radicals, or our perfect squares, is closest to the original radicand. So we just take our original radicand, and do some subtraction. So I'm going to subtract 81 from it. I get a difference of 2. And then I'm going to take the larger perfect square and subtract our radical from it. And I get a difference of 17. So which one has the smaller difference? 2. And what that's saying to me is that the smaller the difference, the closer those two numbers are to each other. We associate that 2 with that perfect square of 81. We associate that perfect square of 81 with the answer 9. So we have just answered the question, or the statement we need to estimate to the nearest integer. So what I write for my answer here is 2 wiggly lines. That means approximately. And we would have 9. Now, to continue on to Mr. Witt's method, what he said to do is take the smaller perfect square's square root. Okay, so that says go with the 9, which, again, since my number is between 9 and 10, 9 would be the smallest whole number value in my answer. I couldn't pick 10 because then it would be over 10. Then I'm going to add to it a fraction. And that fraction is going to be in the numerator. I'm going to do the same subtraction problem I did between the radicand and the smaller perfect square. And then I'm going to do the difference in the two perfect squares. And we're going to get 9 and 2 19ths. 83 take away 81 is 2. 100 take away 81 is 19. Is that rounded to the nearest tenth? No, it's a fraction. So how do I get a fraction to become a decimal? I'm going to do division. So that's what we get to do next. And we're just going to worry about the fraction part because we already know my answer has a 9 in it. So we're going to put in a decimal point, adds a 0, and then start dividing. 19 goes into 20 once, with 1 left over. Actually, it's not 0.1 repeating. And that's as far as I need to go. Is if I want to round to the nearest tenth, I need to go to the hundredths column, because the hundredths number is going to tell me what to do. So at this point, this is what I have for an answer. But now, I need to round to the nearest tenth. The 0 is in control. What does 0 do to 1? Keep it the same or bump it up to 2? Keeps it the same. So you would say for your final answer here, it would be approximately 9.1. Okay? So we're going to go back to the even page. For me, I'm going to go to a new screen. But but I'll label it even page. We're going to talk about the process. And the process on the left will end with the estimation to the nearest integer, and then we'll continue on the right in a column to how do we get to the nearest tenth. Okay? Thank you. So, number one thing we did is we figured out our perfect squares that are radicand fell between. So, find the two perfect squares. Remember, you're going to try to do this in two columns. Your radicand falls between. Two, take the square root of each perfect square. Take the square root of each perfect square. Once we did that, then we needed to figure out which perfect square was closer to our radicand to figure out which square root is closer to our answer. So we use division or subtraction for that. So we're going to subtract each perfect square and the radicand. Four, the smaller difference goes with the perfect square closest to the radicand. So the smaller difference goes with the perfect square closest to the radicand. That's not the answer yet, but now it's going to lead me to the answer. 5. The square root of this perfect square is the answer to the nearest integer. All right, so we've done half of what you're going to be asked to do on some of your problems. Some of your problems are just going to say round to the nearest integer. Some of your problems may say round to the nearest tenth. Okay, so let's talk about what Mr. Witt did in the video to get to that nearest tenth. Okay, that was the name of the teacher, Mr. Witt. To round to the nearest tenth, create the following mixed number. What's a mixed number? Okay, so it's got a number part and it's got a fraction part. Okay. So instead of me putting numbers here, I'm going to put words here. So I'm going to color code this so we can see the difference. So the whole number part of the mixed number is the smaller square root. In the example we did, that was the 9. Then we're going to add a fraction bit. The numerator is going to be the radicand, That's the number under the radical minus the smaller perfect square. By the way, it's the same as this. You've already done that work. Okay? You already did that in step 4. So you already know what that difference is. The denominator is going to be the larger perfect square minus the smaller perfect square. All right, almost there. Oops, change back to black. Step 7 is we're going to simplify the fraction by doing the math. And then we want to create a decimal from the fraction, so then we're going to use division. So then divide the fraction to create a decimal. And then last is going to round the answer to the nearest tenth. So in other words, when you're doing the dividing, you can stop after you have 2 digits after the decimal, because that's all you need to round to the nearest tenth. So we're going to go back to the odd page, and our second example is the square root of 170. So what are the 2 perfect squares that 170 falls between? What was I heard blah blah blah. 169 and 196. But we're not interested in those numbers. What we're interested in is their square roots. Okay, we're going to use both the perfect squares and the square roots. So the square root of 169 is 13 and 196 is, okay, if the numbers are not consecutive, one right after the other, you know you've picked the wrong 2 numbers. So keep that in mind too. All right, so now we want to figure out which one is closer to, and I know sometimes kids say, well, I can just tell. You got to do the subtraction because you're going to need it anyway for the next bit. So we subtract our radicand and this smaller perfect square, we get a difference of 1. We're going to subtract the larger perfect square in our radicand, and we get a difference of 26. So this is pretty obvious. Which one is the smaller difference? 1. That pairs up with 169, which goes with the answer of 13. So our first answer would be approximately 13. But we want to know how close to 13 are we. Okay, so this is where we go to the next bit. So now we're going to create a fraction. And that fraction has the smaller square root, so 13. And then we're going to add to it the fraction, and in the numerator of the fraction is going to be the difference between the radicand and the smaller perfect square. So that's what we did over on the left where we got the difference of 1. And then we're going to do in the denominator, it's going to be the difference of the 2 perfect squares. So this gives us the mixed number 13 and 1/27. Now again, we need to go to decimal, so we're just going to worry about the 13, or not the 13, but the 1/27th, and we're going to divide 1 by 27. Put in a decimal point, add a 0. Oh, 27 can't go into 10, so I hold the place with a 0. Put in another one, and 27 goes into 100 only 3 times, because 4 would take it over 100. So everybody's writing these down. And then there's a difference of 19. As long as that difference is smaller than my divisor, the 27, I'm good. So now my 13 and 1/27th becomes 13.03. And that's, again, as far as we go with the division. But we're not done, right? What else has to happen? We need to round to the nearest tenth. So we have a 0 in the tenths column, and the next door neighbor is a 3. What's the 3 going to do to the 0? Keep it the same or bump it up to 1? It's going to keep it the same. So our answer to the nearest tenth is 13.0. So the question I ask, is it necessary to have that 0? And the answer is yes. And it's the reason why is the direction said round to the nearest tenth. So when it says that, then we're forced to put something in the tenths column, even if it is just a 0. Okay? All right, let's do one more because we've got time. And the one more is going to be a decimal. He did a problem with a decimal, so I thought it would be a good thing for us. Oops. Yeah, we're not going to do that one. We're going to do this one. 44.8. Square root of that. Okay? So, job 1, what are the two perfect squares that 44.8 fall between? Oh gosh, you should know this one.
36 and 49.
Here we go. Sometimes you guys get so caught up on having to look it up and you actually know these numbers, okay? So again, we take their square roots. Square root of 36 is 6. And square root of 49 is 7, okay? Now we're going to figure out which value we're closer to, so we're going to do some subtraction. So 44.8, take away 36, so I line up decimal points, add zeros if I need to, and then subtract. Rename as I need to. So I get 8.8, and then I have 49. I'm going to put 0.0 because I need to subtract the 44.8 from it. Shh. So we rename, we get 10 take away, 8 is 2, 8 take away 4 is 4. Which one has the smaller difference? The 4.2. That went with the 49. 49 goes, its square root is 7. So our answer is approximately 7. That's to the nearest integer. But let's keep going because we want to get it to the nearest whole number. Now, you always write the smaller square root. Because if I put the 7, then the answer I'm going to get is over 7. But my answer has to be between 6 and 7. So then we're going to add. And in my numerator, we're going to have the 44.8 minus the 36. Again, that's going to be this answer here. So you don't have to recalculate it. You should have it already calculated. The denominator, oh, here, let me color code. So that's this guy. And then the denominators, or the, I'm sorry, in the denominator goes the difference of the perfect squares. So at this point, we have 6 and 8.8 thirteenths. It's between 6 and 7. I'm supposed to put the smaller square root as my whole number part. Okay. Next, I'm going to do division. Shh. 13 goes into 88 6 times, which is 78 with a difference of 10. And 13 goes into 107 times, which is 91 with a difference of 9. So what I have is 6.67. But I do need to round to the nearest tenth. What's the 7 going to do to the 6? It's going to go up. So my answer is approximately 6.7. Okay? That's what's going to be on your homework tonight.